Okay, so let's talk about probability. Probability is just a way of giving prediction about something, and the total certainty of probability is one. So we are going to, this is when probability is done to predict if an event will occur or not. It's either it occur or it doesn't occur. So there's a way you measure it, and there's a way you make a prediction. Now, once again, I'll leave you to read all this. I'll just explain the important part of the topic. Like I said the other time, probability of an event is a number from 0 to 1 inclusive. And let's do some example. Consider the following experiment. A box contains 15 pieces of paper, each of which has the name of one of the 15 students in the class, consisting 7 male and 8 female, all with different names. The instructor will shake the box for a while and then, without looking, choose a piece of paper at random and read the name. Here, the sample space is a set of 15 number. Now, sample space, as we're talking about, is just the total number of outcome and number. The set of possible outcome of random experiment. So the assumption is random selection means that each of the name is equally likely to be selected. So this probability, talking about probability, everything must be treated equally, and there must not be bias. If there is assumption that if this assumption is made, then the probability that any particular number is selected is. Now you're talking about if any number is going to be selected, because they said one will be selected right from the box, and we have the total of 15 pieces of box, and we have 7, which is divided into 7 and 8, 7 for male, 8 for female. Now if you are going to pick, if they ask you to calculate the probability for selecting one student name, that will be 1 over 15. 15 is the total number of chances, or the sample space, then 1 is them. So that will be the number of names of the event. That's 1 over 15. That's what they're talking about here. 1 over 15 for event E to happen. Now, if M is the event of student selected is male, so for a male to be selected, if you look at it, since they said out of this 15 pieces of names, there are 7 male and 8 female. It means that this 7 male, the chance that a male student will be selected is 7 over the total number of pieces, which is 15. So 7 over 15. So the total number, so the formula of probability for a particular event is the total number of the names in the, well, don't let me put names now. Let me just put general, but let's just the number of the event E over the sample space, which is 15. So for male, it's going to be 7 over 15 because we have in total 7 male names. For female, since we have 8 females, if you are asked to look for the probability that 8 students will be selected, that will be 8 over 15. So I know this topic might not seem, because it's not like a calculation that you just, it's a calculation, but it's somehow flexible somehow. So you need to reason along the line. So PE, which is the event E, probability of event E, is the number of outcome of event E over the number of possible outcomes in the experiment. Now, there are some things you need to know. Okay, let me continue. In the case of rolling a 6-sided die, if the die is fair, then the 6 outcomes are equally likely. That means there's no bias. So the probability of rolling 4. So we have 1 to 6, right? For a die, you have 1 to 6 for a die. Now, if that's asking you that probably that 4 will be picked out of this 1 to 6, that means that will be 1, because that's just 1 here, 1 over 6. So that's what they're talking about. So since you have only 1 4 here, so that will be 1 over 6. That's what they're talking about here. That's why 1/6. And the probability of rolling an odd number is what? So if you are asked to roll the probability of picking the odd number, that will be you pick the total number of odd number between 1 and 6, which is 1, 3, and 5. And those are 3. 1, 2, 3. So 3/6. And that will give you 3/6, that will be 1/2. And the probability is 1/2. If you are asked to, let's say if you are asked to calculate the probability of picking even number, so you go back to it, that will be like even number, look for even number, that's 2, 4, and 6. That will still be 3/6. That will be 3/6. That's the same thing we have there. Now, these are the things you need to know to your heart. These are the basic things you need to know in probability that will help you to solve questions. Now, if an event E is certain to occur, then the probability of E is equal to 1. I told you the total probability is 1. So if the event is going to occur and you are sure 100%, it's going to be 1. If an event E is certain not to occur, then probability E will be 0. If an event E is possible but not certain to occur, that means it's possible, it's not, we are not sure. So the probability will be between 0 and 1. So it will be between 0 and 1. So that's what is written here. The probability that an event E will not occur is equal to 1, which is the probability that the event will occur minus probability that P will occur, that would be PE. That's probability. This P is the probability that the event will occur. So we can only have two ways. Either the event occur or it doesn't occur. So if it doesn't occur, since the total probability is 1, then you minus the probability that the event will occur to get the one that will not occur. So we can also use this to get the other side. If E is an event, when the probability E is the sum of the probability of the outcome, I didn't get that. If E is an event, then the probability of E is the sum of the probability of the outcome in E. Okay, they are telling you that if E is the event that happens, then the probability of E is the sum of the probability of the outcome in E. So then let's move to the next one. The sum of probability of all possible outcome of an experiment is 1, like I've said that earlier. If E and F are two events of an experiment, we consider each event related to E and F. The event that both E and F occur, that is full outcome, is the set of N intersect C, that they both occur. That event E and F occur, it means E intersect F, that they occur together. That's similar to when I'm talking about sets here. Talking about Venn diagram here. This place, the probability that there's an intersection, they have two things in common. So when they put, so that's just that. The event that E or F or both occur, that is all outcome in set E and F. So that means E union F, that means the combination of E and F. Okay, let's move on. Event that cannot occur at the time is, okay, this is very important. Event that cannot occur at the same time are said to be mutually exclusive. They can't occur, they must happen differently. They can't occur together, so they are mutually exclusive. So the other one will take place without the presence of the other one. For example, if a 6-sided die is rolled once, the event of rolling an odd number and even number are mutually exclusive. That means you can't, when you throw a die once, you cannot have, it's not possible for you to have even number and odd number at the same time. You must have one. Either you have an odd number, you have an even number. That's what they're talking about. That's when it's mutually exclusive. Mutually exclusive means they happen differently, not the same time. But rolling a 4 and rolling an even number are not mutually exclusive, because 4 is actually an even number, because there is a possibility that you roll 4. You understand? That's why 4 is an even number, so it is possible. Since 4 is outcome that is common to both events. Now, I'm just taking my time to read through because I know probability can be quite funny. For event E and F, we have the following rules. You need to know this. Probability of E or F or both occur. Now look at it. When you are using or, we are talking about two events, right? When or means addition. So probability that when you say or, so or means PE, probability of E plus probability of F. That's what you're talking about when probability of E or F occur or both occur. This is the formula PE plus PF minus P both E and F. This P both E and F means P E intersect F. Is inclusion exclusive principle applied to probability. If E and F are mutually exclusive, then P intersect F or P and F is 0. This will be 0. So it will now be PE plus PF. That's mutually exclusive. So that's what we have. Therefore, P or F equals to PE plus PF if they are mutually exclusive. So this is when it is mutually exclusive. This is when it is independent. So add that into your head and write the formula down. Now, E and F are said to be independent if the occurrence of either event does not affect the occurrence of each other. If two events E and F are independent, then both E and F equals independence is different. Here, this formula applies for mutually exclusive. Down here. So if we have probability of E or F, you have this formula PE plus PF minus P both E and F. This PE and F means E intersect F, right? But if they are mutually exclusive, it means this is 0. That's what they said here. So that means you have PE plus F. Depends on the information you have in the question. For here, so when they happen independent, that means they happen differently. They do not affect each other. So it means they have PE and PF. That's together. So that this PE and PF is the same. This is the same as this. What we have here. So that means P both E and F. PE, PF. There will be multiplication. P intersect. This is the same as P intersects. PE intersects F. Now, for example, if a fair six-sided die is rolled twice. Now, let me show you my own strategy. So, I concluded that for independent formula, if the two events are independent of each other, this is the formula P plus PF minus P into E intersect F. Now, P intersect F is the same as this PE times PF. So that's the formula. So you can just get to know that if they are mutually exclusive, it means PE plus PF. Simple, because this will be 0. Mutually exclusive. So that is the summary of what I did here. Now they are telling you that's the message they are trying to pass across. Now let me read this. For example, if it's fair six-sided die is rolled twice, so it is rolled 2 times. The event E of rolling 3 on the first row and event F of rolling 3 on the second row are independent. That means happen differently. No, independent is there, the very keyword. And the probability of rolling 3 on both is PE and PF. So this probability of rolling 3 are, okay, as the intersection. Now, okay, and the rolling 3 on both is this. Now, if you have to calculate for this question, so since the probability of for the first event, that's 1/6, because you can only have 1 3 out of, no, we're talking about die now. Die has 1 to 6, Abby. So multiply by 1 to 6. 1 to 6 for the first one, second one 1 to 6. That gives us 1/36. So that is why this is like this. Probability can be quite funny sometimes, but you need to understand it. So I will continue from the next video.